Good evening, friends. Welcome to the 360 Digit MG interview preparation session. I am Aisa Fatima. So let's start the session. Let me share my screen. So we'll start with the questions. So our first question is, what is bias theorem? What is bias theorem? So bias theorem is nothing. Here what we do is we find the probability of an event when occurring given the probability of another event that has already occurred. So we need to find the probability of an event, how it can occur. There we have already given the probability of another event that has already occurred. So what is the mathematically formula for the same? Here we have the formula is, if we have A is one event and B is another event, so here we are getting the probability of one event. So probability of one event, that is A by B, equals to P probability of B by A in probability of A divided by probability of B. So when there is A is one event and B is another event, and we need to find out the probability of one depending on the other, then that is the probability of A by B, which is probability of B by A into probability of A total divided by probability of B. So this gives the probability of one event occurring already given event is A. So that is the formula for bias theorem. So next, what is the assumption of naive Bayes classifier? What is the assumption for the theorem? What is the assumptions of naive Bayes theorem? So the fundamental assumption of this theorem is each independent variable is independent and equally contributes to the outcome. So every variable is independent and they contribute towards the outcome of the total. So that is the main assumptions of naive Bayes theorem. Then what is SVM? What is SVM? This is also called as black box technique. So in SVM, we plot each data point in n-dimensional space with the value of each dimension being the value of a particular coordinate. Then we perform the classification by finding the hyperplane that differentiate the classes very well. Okay, so that is SVM. So here are we have some parameters. So we do the hyperparameter tuning. So what are the parameters we have for SVM? What are the tuning parameters What are the tuning parameters of SVM? So here we have the parameters as kernel, regularization, gamma, and margin are the tuning parameters of SVM. So these are some of the tuning parameters of SVM. Those are kernel, regularization, gamma, and margin. So those are the parameters here. So when we say kernel is a hyperparameter in SVM. So what is kernel in SVM? We'll understand. Let's explain what is kernel in SVM. So kernel tricks are nothing but the transformations which are applied on the input variables. So kernel tricks are the transformations are applied on the input variables which separate the non-separable data to separable. So when we get the problem, when we can't segregate or classify the input variables, then we need this kernel method or kernel trick to differentiate or classify the data, like to separate the data into different class. So there are 9 different kernel tricks. Some of the examples are linear kernel method, then RBF kernel method, then polynomial kernel method. So there are other kernel methods are there. Then what is a decision tree? What is a decision tree? Decision tree is a supervised machine learning. We have 2 types of learning. Supervised, 3 types of learning actually in machine learning. So supervised machine learning, unsupervised, then reinforcement machine learning. So decision tree is a supervised machine learning algorithm which is used for classification and regression analysis. So it is a tree-like structure. So for that reason, it has the name as per the same decision tree. So it has a structure which is like tree in which internal node represents test on an attribute. So each branch represents outcome of test and each leaf node represents class label. So it is a structure of tree. So there are branches which represents the outcome, and there are each leaf node represents the class level. So it is a decision tree. So what are the rules in decision tree we have? What are the rules in decision tree? So the rule is nothing but this is a path from root node to leaf node. So as it is a structure of tree, so which starts from root node and it will be ending on leaf node. So there is a path from root node to leaf node. So that represents the classification rule. So this is the rule for decision tree. What are the different types of nodes in decision tree we have and how are they selected? Explain about the different types of nodes in decision tree and how are they selected? How are they selected? So we have root node as it is a tree-like structure. So we have root node, then we have internal node, then we have leaf node in a decision tree. So these three nodes we are having here, which is root node, internal node, and leaf node in a decision tree. So this decision tree starts at the root node, and this is the first node of the decision tree. So when the data set is splitted based on its root node, again nodes are selected to further split. Those are already splitted data. So this process of splitting the data goes on till we get the leaf nodes, which are nothing but the classification labels. So till we get the classification labels, the split will be going on from starting the root node. And in this process, there will be some internal nodes. So using the statistical measure, we will be deciding the internal nodes. And this measure is called gain. So when we are doing the splitting, there will be some gain, which is using some statistical measure. So what do you mean by impurity in decision tree? What do you mean by decision tree? Sorry, impurity. Impurity in decision tree. So when we say a data set is pure or homogeneous, then all its class levels is the same. And when we are saying the data is impure or heterogeneous, then the class labels are different. So entropy or Gini index or classification error can be used to measure the impurity of the data set. So when there are some noise or error in the data, so that is called the impurity in data set. if we don't have the impure data, then it is the pure data, so it resembles, it belongs to same class. So mostly we have the impure data only on which we will be working on. That is called the impurity in decision tree. So what is pruning? What is pruning in decision tree? So when we are working in on decision tree, mostly we face the problem overfitting. So to overcome that problem, we use pruning in decision tree. So what is that process? So pruning is a process of removal of subnodes which contributes less power to the decision tree model. So that is only called the pruning. So the reason for which we are getting the overfitting problem is we are having number of subnodes. So in this process of pruning, we are just removing the subnodes which doesn't contribute towards the model. So what is the advantage of pruning? What is the advantage of pruning? So prune, as I already said, that pruning reduces the complexity of the final classifier and hence improves the predictive accuracy. So by reduction of overfitting. So to overcome that overfitting problem, which is coming from the complexity of the data set, so that reduces the complexity of the data, so we get the good accuracy without having the overfitting problem. So that is the advantage of pruning. What is the difference between entropy and information gain? What is the difference between entropy and information gain? So when we are saying talking about entropy, so entropy is nothing but a probabilistic measure of uncertainty or the impurity. The impurity which we have already discussed. So when we are talking about the entropy, it is the probabilistic measure of uncertainty or the impurity, where the information gain is the reduction of this uncertainty measure. So entropy is the measurement of the uncertainty, and the gain is by gain we reduce the uncertainty measure. So by entropy we can measure the same, and with the information gain we can reduce that. So that was the difference between entropy and information gain. So next. So what is we got the difference between entropy and gain, but what is exactly the expression of gain of any column? So we'll talk about the expression. Sorry. Explain the expression of gain of any column of variable. So what is gain? So gain for any column is calculated by differencing information gain of a data set with respect to a variable from the information gain of the entire data set. So when we are calculating the gain for one particular column, then we are differencing the information gain of a data set with respect to a variable from the information gain of the entire data set. So that is gain of the entire data set is, suppose we have a column age. So gain of age equals to information of total data set, which will minus information of with respect to age. So that difference will be the gain of particular column. Then we have random forest. So what is random forest? What is random forest? So random forest is an ensemble classifier. random forest is an ensemble technique when we where we do the classification. So it's an ensemble classifier. So as opposed to a build a single decision tree, random forest builds may decision trees and combines the output of all the decision trees to give a stable output. Why? Because we are getting that overfitting problem with the decision trees. So with the just opposite to the decision trees, with random forest, we build many decision trees and combine the output of all the decision trees to give a stable output. So that is random forest. So how does random forest adds randomness and build a better model than decision tree? How does random forest adds randomness and build a better model? So instead of searching for the most important feature when we are splitting a node, it just searches for the best feature. So it is when we are searching for the most important feature when splitting a node, it searches for the best feature among a random subset of features. So randomly it select the features, and out of that it searches for the best feature. So this results in a wide diversity, which generally results in a better model. So additional randomness can be added by using random thresholds. So we can use random thresholds for adding a more randomness to the data. So for each feature, rather than searching for the best possible thresholds like a normal decision tree does. So that is how the randomness adds a randomness to the data and build a better model than decision tree. So what are the advantages of random forest? What are the advantages of random forest? So random forest won't overfit the model first of all, and it is unexcelled in a reliable accuracy. So it gives a reliable accuracy which doesn't give any overfitting problem, and it also works very well on a larger data sets, and it can handle thousands of input variables without deletion or output significance of input variables, and this also handles outliers and missing values very well. So these are the advantages of random forest where we face the problem in decision trees. So these are so when we are using the random forest, we have these advantages. So what are the disadvantages of or limitation of random forest? What are the limitations of random forest. So the main limitation of random forest is that a large number of trees can make the algorithm too slow and ineffective for real-time predictions. So here in random forest, as we know, we have a lot of number of many decision trees we have. So it makes the algorithm to work slow, and it can be ineffective for real-time predictions. So in most real-world applications, the random forest algorithm is fast enough, but there can certainly be situations where runtime performance is important, and other approaches would be preferred. Then what is a probability distribution? What is the probability distribution? So probability distribution is a function which provides the probabilities of occurrence of different possible outcomes. So when we are trying to predict the outcome of some variable or any data in an experiment, then we use this probability distribution function. So in a probability distribution, random variable is plotted on x-axis and the associated probabilities are plotted on y-axis. So the variable will be plotted on x-axis and the probabilities of the particular variable will be plotted again on the y-axis. So that is probability distribution. What are the classifications of probability distributions? What are the classifications of probability distributions? So probability distributions are categorized into two. One is discrete probability distribution and one is continuous probability distributions. So these are two classifications of distributions. So in the discrete probability distribution, we have underlying random variable which is discrete, whereas in continuous probability distribution, the underlying random variable is continuous. So on basis of the random variable is if the random variable is discrete, then we have the discrete probability distribution, and if the random variable is continuous, we have the continuous probability distribution. So what do you mean by a discrete random variable? Discrete random variable. So a discrete random variable is a random variable which has countable values. The values, if we can count them, so those are the discrete values such as a list of non-negative integers. So if we have a list of non-negative integers, then we have the countable values, and those variable are called discrete random variable. So some of the examples of discrete random variables are number of students present and uh, number of cars in a parking lot, number of heads when flipping 3 coins, students grade level, and so these are some of the few examples of discrete random variables where we can count the frequency of the variable. So those are the discrete random variable examples. So after that, what do you mean by continuous random variable? What do you mean by continuous random variable? A continuous random variable is a random variable with a set of possible values. So we know the range only over there, and the values will be lying within that range. But it can be any value from that range only. It can that is infinite and uncountable. So we can have infinite values from that range. So those values will be continuous values. So that variable we can call it as continuous random variable. So we can talk about some examples of continuous random variables as well. So which can be a height of students in class, so weight of students. So like this variables when we have, so height can be go into a, like we can represent it in decimal points, and to any extent we can measure it. If we represent the number to any extent in the decimal values, so it will give us a meaning, so that will be valid. So that is continuous variable. So these are the continuous random variables. And again, at a time it takes to get to school, distance traveled between the classes are a few examples of continuous random variables. After that, what do you mean by expected value? What do you mean by expected value? So expected value, which is also known as mean value, we call it as mean value as well. So is the expected outcome of a given experiment. So when we are trying with some data set and we are experimenting something, so we are expecting some outcome over there. So that is the expected value, which is calculated as the weighted average of all the possible values. For that reason, it is also called as mean value. So it is nothing but the average of all the possible values of a random variable based on their probabilities. Then we'll talk about data types. So what do you mean by data types? So in programming, a data type is a classification that specifies which type of value a variable has. When we are working with a data set, it has number of columns. So those columns are the variables. So for each column, what kind of values we are having in the data set, so that we need to specify. So that classification uh, which we do for a value of a variable has what kind of values and what type of mathematical or relational or logical operations can be applied to it. So it should not cause any error to the same. For that reason, we should know what is the data type. So data type is the classification which specifies the type of value a column is containing. So on basis of the data type, we can apply the operations or functions to the particular variable. So what are the classifications of data types in statistics? What are the classifications of data types in statistics? So we have qualitative, quantitative. So these are the two broader classifications. So qualitative means it will explain the quality of the data, and quantitative is the numerical measure of the data. So we have these two broader classifications of data types, which is qualitative and quantitative. However, these are further classified into nominal, ordinal, interval, and ratio data types. So uh, mainly it is classified into two. So further we can divide it into these further classifications as nominal, ordinal, interval, or ratio data types. So after that, what is the difference between a nominal and ordinal data type? So what is nominal data type and what is ordinal data type? What is the difference between nominal and ordinal data type? So a nominal data type simply is a name or a label. So nominal data we can guess from its name. So it's a name or a label. So language is spoken by a person. Jersey numbers of a football players are the examples of nominal data type. Whereas uh, on the top of being a name or a label, ordinal data type has some natural ordering. So from this name also we can we come to know that we can order this data type. Whereas in the nominal data type, we can't order the data. Why? Because that is the categorical data. So for ordinal data, it has some order, so we can sort it out. So we can put it in a order. So some order is associated with it. So some examples of this ordinal data type is shirt size. So like a scale rating, so ranks of a competition, then educational background of a person. So these are some examples of ordinal data types. So there we have the levels of this these things, so we can order, we can sort it in a order. So these are ordinal data type. How is interval data type different from ratio? How is interval data type different from ratio? So interval scales are numeric scales. So in which we know not only the order but also the exact difference between the values. So from the name itself we can understand that. So it is a interval. So there is some range on that range only it will be having the values. So that is the interval data type. But the problem with interval scales is that they don't have a true zero. It lies within a range of values, but it doesn't have a true zero value. So that is the main problem with the interval data type. And temperature and dates are the examples of interval data type, where we don't have a zero value. We can't say there is a zero date or zero temperature. Zero temperature is also temperature. So in that way, it is a problem. So whereas ratio data type tell us about the order, exact value between the units, and they also have the absolute zero values. So some of the examples of ratio type of data are heights, weights of people, length of an object, the distance covered by a vehicle. So these are some ratio kind of data type, ratio type of data. Why the data types are so important? Why the data types are so important? So when we are doing applying any statistical method, so be it descriptive or predictive or prescriptive, so we can it can be employed only based on the data type of the variable. When we don't know the data type of the variable, we can't predict anything over there. So for that, correct identification of data types leads to the correct modeling and correct solution. If we don't identify the data type correctly, then we can't do the proper modeling and get the correct solution to the problem. So for that reason, we should have the correct identification of the data types. So data types are very important. We talk about the interval and ratio data type. There we talk about absolute zero value. So what is that absolute zero value? What do you mean by an absolute zero? So absolute zero means true absence of a value. So we do not have any absolute zero in interval data type. So, but in ratio data type, we have one such example of zero. One of such example is when we say 0 Celsius temperature, but that doesn't mean that there is no temperature at all. So, but when we are talking about the number, the distance covered by a person. So there we can't say there we can say that the person didn't cover any distance. So there we can say a zero value. When we are counting something, if we don't have the anything is not present over there, then we can say that so zero value is there. So there we have the zero value for ratio for, but for interval data type we don't have absolute zero. What is the factor variable? What is a factor variable? So factor variable is a variable which can take only limited set of values. So the variable which can take only a limited set of values are the factor variables. So in other words, we can say the levels of a factor variables will be limited. What are the different types of discrete probability distributions? Discrete probability distributions. So there are a number of different types of discrete probability distributions, which are binomial probability distribution, Poisson's distribution, negative binomial distributions, so geometric probability distribution, hypergeometric probability distribution. So these are some of the examples of discrete probability distributions. So what are the examples of some continuous probability distributions? What are the different types of continuous probability distributions? So what are the different types of continuous probability distributions? So we have a normal distribution, exponential distribution, t distribution, f distribution, chi-square distribution, uniform distribution. We also have a variable distribution. So these are some few examples of continuous probability distributions. So today we have discussed about decision tree, random forest, then probability distributions and data types. So that we have already discussed this much. So that was for all today. So thank you, friends, and thank you for attending this session. Thank you so much.